Hello and welcome to the quick start guide for the ChipWhisperer-Lite device. So this is going to teach you how to get started with the ChipWhisperer-Lite and do a very basic power analysis. So this demo is going to use Windows 7, but the basics are applicable across other operating systems, although the driver installation details will be a little different. So to get started, everything is always referenced from, if you go to ChipWhisperer.com, and this will redirect you to, right now the wiki's on Assembler. This might move, but it always redirects you to the main page. So one thing to note is that the majority of the documentation actually isn't in the wiki, but is on a separate page that has this full Python documentation link. This full Python documentation is HTML documentation built from the Python module, and it's included with the release, or you can access it online. There's a link there. So this isn't duplicated in the wiki, just so you're aware. So the first thing, and where this quick start guide lies, is if I'll pull over another window with the documentation here. In the main page, there will be this new AE hardware products as part of the documentation. And right now it has, this ChipWhisperer-Lite board has a little bit of a quick start. There is also a more advanced details, and there's install lane, which includes various methods of installing it. So I'll just be going over the quickest one for Windows right now. So the first thing we need is what's known as a Python distribution. So I'm going to use Windpipe, and here we go. Follow the link. And so this includes Python, which is what ChipWhisper relies on, but more importantly, it gives you a useful tool that if you want to do more advanced analysis, you can. So that's why, and we just keep following the links. Okay, there we go. That's why there's no all-in-one installer for ChipWhisper, because you may need these additional tools. So the critical thing is we need to download WinPython 2.7, not 3 point anything. So it has to be the 2.7 and whatever the latest 2.7 branch is. Right now it's this 2.7.10.1, and I'll hit downloads. And this will give you a choice of a installer, either 32 or 64-bit. So both can actually be useful. So the 64-bit can be useful if you're doing analysis that might require more memory to do longer analysis. So that's really useful. If you use some of the more advanced tools, though, some of the drivers, so if you want to interface to smart cards, only work with the 32-bit version of Python. So your version of Python has to match any DLLs you link against. In this example, even though I have a 64-bit machine, I'm going to install the 32-bit Python. So I encourage you to start with this, and you can actually install both if you want. So run one in one version of Python, one in the other. But it's up to you. Most of the core modules will work across 32 or 64-bit. So the download will start, and it does take a little bit to download and install. So I'll pause it once we start downloading here. There we go. So this is all the default, Windows 7. I'm using a clean install here, so that's why it's all Internet Explorer and everything like that. So we'll wait for that to download, and then we'll run the installer. All right, now that this is finished downloading, you can just run the installer. So note, all the installer really does is it just copies a whole bunch of files to one location. By default, it's going to ask to copy it where it downloaded it. So what we want to do instead is copy it to some useful folder for us, like maybe our documents folder, or where I'm going to copy it is actually straight to the root of the C drive. That makes it really easy to always find the location. So you don't have to do these exact one, but you can see by default it's in the download, so that's not a very good spot. So I'm just going to put it in the root of the C drive. You could put it somewhere else if you want. And we'll hit install. And I try to avoid spaces in this path. Theoretically, I think the stuff should work with spaces fine, but just in case, it's easier because you'll be also installing additional additional modules beyond just the ChipWhisper stuff. So this does the install, which, as I said, there is nothing. All it's doing is copying everything. It doesn't, by default, make any program menu entries or anything like that even. So it's really just copying. And besides straight Python, it has some really nice apps like Spider. So this we can use. It's a bit, if you use MATLAB, it's a tiny bit like that, but you can do interactive graphing, interactive data analysis. So when you go to do some of the more advanced tools, you can use this as part of your data analysis to do stuff outside of the ChipWhisper software. So you'll see later tutorials will go through the use of Spider, or basically using outside Python. So once it's installed, we can close that. So one thing you can do if you want, if you open this WinPython control panel, give it a second to open, you can use it to install or update packages, and you can do this if you want. You can register the distribution. I won't do it here, which what it's going to do is it's going to add it to the path, add it to the start menu. This can be really useful if you don't have Python before. This means that you can just run Python from, if you just run a command prompt, you would have Python here. By default, you don't. So it's up to you. I'm not going to do it just to show you how to do it without doing that, installing it to path. So if you don't, we need to open this WinPython command prompt. So this is really just a command window with Python in the path. And so I can exit with using quit after I've run it, for example. Now, we don't care about that. What we're going to do now is install some required information. So this, it goes through this in the quick start guide. So basically we've got to install a few extra tools. So PyQtGraph, config.obj, and PyUSB. So let's do this. And we'll use this pip tool. So if we just type pip install PyQtGraph, it should pull in all the dependencies we need. In this case, it says requirement already satisfied. So this version of WinPython already has PyQtGraph. Perfect. So don't need to worry about that. Config.obj. And so now it will try to do the install for us. And you can see it says successfully installed, so we're great. And final one, pip install PyUSB. And it'll try to do it. So successfully installed. As a note, sometimes once or twice I've had it where it errors out, and all you have to do, this has gone through in the documentation, but you have to specify the specific version. So you might have to say B2 or B1, whatever the latest version is. This is when there's multiple. All right, so that's about it. So that set up our command prompt, or set up our Python distribution and installed the required tools. So next, what we can do is actually install the ChipWhisper. So what this is going to do is this will copy the ChipWhisper, or make a reference to the ChipWhisper tools to in Python. So to do this, we're going to go back to ChipWhisper, and we go to the ChipWhisper release page, and this is just the latest software releases. And all the ChipWhisper releases is a zip file. So in this case, the latest that you should be using is there will be a 0.11. But it just says, hey, what do you want to do? And we'll just save that. So to save time, I'm actually going to use the latest release here. And we take the zip file and just extract this, copy this whole directory somewhere. So wherever you want your working directory to be, you just copy the contents of that zip file. I'm actually going to copy it right to the root C drive. That's just my prerogative. You can put this somewhere else. You could put that in your user directory or something like that. And I'm just going to rename it to ChipWhisper. So this is how the tutorials assume is everything is in this C ChipWhisper folder. So we then have to go back. This is the Python console again. It has to be the one where we can run Python from it. And I'm going to cd to the ChipWhisper directory. And this is all in the quick start guide, OpenADC, control SW, Python. So this is the Python software for half the project that does the analog measurement side. And I'm going to run the command python setup.py. And the last option is develop. And what this does is it doesn't actually copy all of the source files to your root Python directory. It just makes a reference to them. I only do this because there's frequent updates right now, and it makes it a lot easier when these frequent updates change files and you don't have to rerun the install necessarily. I have to run the same command. We have to do this twice. The second time is in the C ChipWhisper software directory, and python setup.py develop. And there we go. So at this point, it should work. So I can cd, for example, to the ChipWhisper/analyzer directory, and I can run python ChipWhisper-Analyzer. And it should run. In this case, it says error, PiSide is required for this program. So what's happened is this particular WinPython distribution didn't have PiSide included with it, so we have to run pip install PiSide. So that'll be in the documentation as well. Again, if you forget this stuff, no need to see it all from the video. So you can see it's going to go through and download and install PiSide. So PiSide is the entire GUI library used by ChipWhisper. And so once it's downloaded, it'll do the install. It's successfully installed. So let's try again. Python ChipWhisper-Analyzer. There we go. So if things work, you got this crazy looking main window. It's only crazy the first time. There's a whole bunch of windows. So when we open stuff up, we can move things around and close. So the Python text editor we don't need. And this analysis script I can move down. Basically all these windows you can sort of move together as you need to. And so this will actually be what we use for analysis, but I'll close that because I'm not actually using it. I was just checking things were working. So everything's good to go. The next thing I need to do is install the ChipWhisper drivers. So to do that, I'll close the Python window, I'll close everything. And what I'm going to do is plug in the ChipWhisper-Lite board. And Windows should do its driver installation. Once the board enumerates, you'll see this blinking blue LED here. So that just means that there's power and the board is not in USB sleep state. It doesn't necessarily mean drivers are installed. So Windows has come up and said, hey, no drivers found. It may automatically ask you where to do them. If not, you can go to Device Manager and go to the ChipWhisper-Lite and hit Update Driver. Now by default, you can either download the driver separately or it's actually part of the ChipWhisper release. So where it's located is Hardware, Capture, ChipWhisper-Lite. You may find if you download an official release, normally there's this there'll be a USB_driver folder. If not, you'll find a zip file, and all you have to do is copy the USB driver to somewhere like your desktop. It's just a temporary thing. And then I'm going to point the wizard to that folder location. So you may have a zip file, you may have the driver folder, depending on the release version. And it should be fully signed, so occasionally it comes up with an error. You can ask for support on the forum if you get that, but it should be a signed driver, so there should be no issues in Windows 64-bit or anything like that. And success. So if you get the warning that it's unsigned, often you can just hit accept anyway. And what happens is the underlying libUSB driver is signed. So even though the ChipWhisper-Lite driver wasn't signed, it almost always seems to still work on 64-bit Windows. So don't be too worried. All right, so now we can start ChipWhispering. So my device is plugged in here, and I'm going to go back to the ChipWhisper folder. If you do the Python register Python distribution, you can use these two shortcuts, or you should be able to use those two shortcuts. But if not, let's open this again. See WinPython. All we have to do is we open the WinPython command prompt, and we've got a cd to this directory, so the software directory. You can try running, it doesn't always work, CW capture.pdiw. Put Python in front of it, and it should just open up. There we go, like this. So this is ChipWhisper Capture. And what we're going to do is rearrange the windows. So there's this project text editor. You can close that. All the windows are at the top here if you need to open them again ever. We don't need it right now. And these three things in the bottom I can get rid of. So very briefly, at the bottom here we have this debug log. So this is anywhere in Python that does a print or prints a message will come here. It sort of varies in message quality depending on the modules loaded. There's a Python console, so this is actually allowing you to real-time adjust parameters within the Python program. So you can see if I hit self, what we're referring to is this exact window. So if you want to do some hacking of the software, you don't even have to modify it and rerun it. You can use Python's sort of interpreted ability straight from this window, and we can do stuff. We can go import numpy as np. So right in this window, we have the ability to get all of the power of Python, and then it can interact with modules within the ChipWhisperer system. We also have this script command is when we change stuff on the GUI. What it's doing is it's printing to this command, and this is used for another interface you'll see in other tutorials where you can programmatically change the GUI settings. So it's pretty interesting that way. Anyway. We want to do a real simple demo, so what I'm going to do is there's these example scripts, and these example scripts just do some basic stuff that configures a whole bunch of settings in the GUI. The first one to do is this AES simple serial on Xmega. So the ChipWhisperer board by default is loaded with, it's actually not quite loaded with the full AES algorithm. Normally it just does the first round of it, and that's just for export reasons. So we'll run this, but it does enough of it that you can do the attack. And what you should see, for example, if I look on the debug logging, we'll see that it says found ChipWhisperer-Lite, prints the serial number, programs the FPGA and stuff like that. So over here on the FPGA, we'll see the heartbeat LED flashing. And that's the green LED at the bottom. And whenever we do a capture, we should see the armed LED flash. So what's going on right here is this is the actual power of the device as it's doing that first bit of the AES crypto library. And we can use a monitor and to view the input and output. So that's sort of the basics of doing the analysis. So what we're going to do is if I set the number of traces to 50 and hit this M button, it's actually going to send 50 encryptions to the device. The device will perform the first round and a bit of AES, and we're going to record the power as that's happening. So what we want to do now is actually use that to break the AES. So I'm going to save that project, and by default it's going to save it in this software folder. Future versions will improve this to save it somewhere more reasonable, but I'm just going to call it test demo. And you can close this now. So that was the capture. We now need the analyzer program. So again, I haven't registered the distribution. I'm going to show you what that looks like, just so you get a full view. So if you want to go register distribution, what this means is now Python is in my path, and I can actually I should be able to run these programs just by double clicking on them. I don't know if I have to log in and out. Nope. So now it actually knows to open Python. As a note, if you double click on it and it doesn't run, what you should do instead is run it from the command prompt. So run it with Python ChipWhisper Analyzer, because you'll see it's going to print some messages. So if it's missing a module or something like that, it's going to print it right here. So in this case, I'm just going to run it like this. And there we go, ChipWhisper Analyzer. So this is the analyzer program. As I mentioned, we can drag these around. And all we're going to do is we're going to go File, Open Project, and run test that file I saved. And if you switch over to the waveform display, you can see this was one of the power traces. And you can play around a bit. So under the General tab, I can redraw, 10 waveforms over top of each other. So this lets me view what was the power difference at various points in time. So you can actually see, for example, this section right here, there's a lot of variation of the traces for different execution paths, whereas other locations, let's zoom in somewhere else, you can see these traces, almost entirely overlap. So you can really see where the data sensitive operations are occurring. Anyway, the final thing we're going to do is we're just going to do a standard correlation power analysis attack. As a note, you can run, there's this progressive-C accelerated. This is just a faster version of the algorithm. The default runs entirely in Python and is a little slower. For this quick start, it doesn't matter. And what we're going to see is the analysis algorithm knows what the correct key being used for the first part of AES was. And that's going to be highlighted in red, and it should start to float to the top here. So we can see one of these bytes wasn't quite recovered, and we can investigate why in a second. And why this is in the output versus plot window, I can turn on, byte 0, and okay, what does this all mean? Well, let me turn on one where it did recover. What this is showing is it's actually showing the location and time where the sensitive data was being used, and we can see it's around sample 1440, and we can turn on later bytes, and we should see this walk forward in time. And if byte 2, byte 3, I'm just going to turn off byte 1 here, byte 4, and we'll see that the next point sort of becomes here. So what's actually happened is I didn't capture enough data at the beginning to recover the data I needed. So that's why I didn't recover that first byte. But otherwise, I performed a complete correlation power analysis attack. So how would I fix that, just out of interest? And when you download, so when you run this demo, you might not have that happen because these scripts are always being fixed in new releases. So this was a bug in an older version. But just for reference, what's happening here is you can start to play with some of these settings. So for example, what's happened is I don't have any data here, and that's because I had a bit of an offset and I had too much offset. So if I change this to 1200, you can see I changed the data that I received. I've got a little more. So I could run the capture again and see if that allows me to recover the complete key. But very briefly, that's how you plug in your ChipWhisperer-Lite and perform your first correlation power analysis attack. So as you're going through the documentation, you'll notice, let me pull over the documentation window here, there's a whole bunch of tutorials. So by default, a lot of them use the ChipWhisperer capture complete, but it's almost the same. It's the same sort of stuff is involved in each one, and you can adjust how they work. So there's a few adjustments needed, but the software interface is the same for the various ChipWhisperer capture products, be the Lite or the original Rev 2 version of the port. But if you have more questions, feel free to ask in the forum or comments here. Thanks for watching.